This video is on the objective graph a circle or a line from a polar equation. Alright, and this is the third video because there are a lot of different scenarios that are coming up here in this, and I want to show you a little bit of everything, as much as I can anyway. So you saw in the first video I graphed what was called a rose, so not a circle or a line. The second video I did graph a line that was going through the origin, right, just theta equals some number. And here's something, another one where we're going to end up with a different kind of graph. So maybe it'll be a line, maybe it'll be a circle, maybe it'll be one of those rows things, we'll see. So let's take a look. Alright, and again, if you want to see more about the topic, click on, at the bottom, more instruction, and look at their videos, their notes, their examples, and hopefully those help. Alright, so let's take a look. I'm going to write this down. We have r equals -2 times the cosecant of theta. So let me write this out. So r equals -2 times the cosecant of theta. Alright, and again I'll draw a pretty rough polar grid. Vertical axis, horizontal axis, right? The polar axis is the horizontal, where the values of r live. The vertical axis is just the y-axis, it doesn't mean anything in polar. And then I'll just, what I'm going to do this time, I'm just going to put these here. So here's 1, 2, 3, 4, 5, and then I'll just draw some circles. Right? Remember, we're traveling on circles in polar. So here's a circle of radius 1, a circle of radius 2, centered at the pole, centered at the origin. Circle of radius 3, circle of radius 4, and this is very rough, and I'll stop there. Alright, there should be a circle of radius 5. And then, here's -1 on the polar, -2, -3, -4 on the polar axis. Okay. So now, again, one thing I can do is I can, start off making a table, if I wish, with values of r, values of theta. And then after I, plug in some values of theta, get values of r, I plot points. So let's see what happens. Well, what if theta is, now remember this is 1 over sine theta, right? Cosecant's 1 over sine. So theta can't be multiples of pi, right? Because the sine of 0 is 0, sine of pi is 0. So I'll start off with a nice value. How about pi over 2? Right, how about pi over 2? What if theta were pi over 2? Remember, the cosecant of pi over 2 would be 1. But then you have times -2, right? So the value of r would be -2. And then when I go to plot points, remember it's r comma theta. So I go to -2. So I'm here on the polar axis. And then I travel positive pi over 2. Positive pi over 2. So from here, go counterclockwise 90 degrees, and I'm here. There's the point, -2 pi over 2. All right, and then I can't, I can't plug in pi because it make me undefined. I can plug in 3 pi over 2. Sorry, 3 pi over 2. And when I plug this in, the cosecant of 3 pi over 2 is -1 times -2 would be positive 2 for r. Let's see what happens here. So I start at positive 2 for r, and I travel from here, positive 3 pi over 2. So that's, pi over 2, 2 pi over 2, 3. Oh man. It's the same point again. And you see how the same thing would happen for 5 pi over 2, 7 pi over 2? I would always land at this point. Alright, so I need some more information. I need to plug in some different angles to see if anything else is going on here. Alright, so that's where this comes in. And you saw me do this in the first video on this objective when I graphed that rose. So instead of r equals -2 cosecant theta, let's take a look at y equals -2 times the cosecant of x, going way back to like chapter 8, chapter 7, chapter 8, I forget. And then graph this. So every time I see y, it's the same as r. Every time I see x, it's the same as theta. But I'm going to graph it on my usual, x, y axes. Now remember, the period of this was 2 pi. So starting at 0, I'll have it end at 2 pi. So that takes me once around, right? That would take me from 0 all the way around to 2 pi, and I'll get the complete graph, right, in the polar grid. So this is the rectangular equivalent. Well, not equivalent, it's just a rectangular simulation, I guess. Then I'll break this into quarters, right? And we got pi over 2, pi, 3 pi over 2. And if you recall, right, remember there were these vertical asymptotes at the multiples of pi. So at 0, at pi, at 2 pi, and the value at pi over 2 here would be, again, -2. And we saw that here. So again, when I say x, I really mean theta. When I say y, I really mean -2. But we're going back to our old graphs. And remember the old graph of this, the graph of this were these U-shapes between these asymptotes. So I had this U-shape here. And then plugging in 3 pi over 2 gave me +2. Right? And again, this U-shape opening up, approaching these asymptotes. And there's a graph of one cycle back in x and y coordinates. Now let's translate these to the polar grid. So first, let's take a look at this part of the graph. Right here, this part of the graph. Right, so this part of the graph, you see, now x is now theta. So from theta equals 0, right, here's theta equals 0, that's this part of that's this line, to theta equals pi over 2, right? Theta equals pi over 2 is the vertical axis. So between these two, I have values of r, right? Values of y correspond to values of r, going from -infinity to -2. Now, since the values of r are negative, my points aren't going to show up between these two. They're going to show up between these two. And having a value of r from -infinity to coming to -2, now again, it's really hard to spot. I would really have to plot some more points, but this is going to happen. I have between these two, but I have negative r's, so I'm between these two. And we're going from values of r equals -infinity. So values of r, points that are infinitely far away from the origin, all the way to points that are -2, 2 units away from the origin. So this kind of connection. And we're going to see it's a horizontal line. In fact, it would be a lot easier to actually just change this to its rectangular version. Change this so that it's the equivalent equation in x's and y's, convert it to a rectangular form, and you'll see that it's the graph of a horizontal line. All right, and then this part of the graph, right, from theta equals pi over 2 to pi. So I'm going from I'm between here and here. I'm between here and here. But again, I have negative values of r. So instead of having a piece of the graph show up between these two, it's going to show up between these two on the opposite side. And the value is going from r equals -2 to r equals -infinity. So from here out forever, right? And you get this graph, right? There's a horizontal line. I get the graph of a horizontal line. And you see, if I were to graph, see what part of this graph corresponds to this part of the graph of this graph up here, it'll be the same exact picture. All right, so I'm going to get a horizontal line here. Basically just y equals -2. Now you can see that a lot more easily. This one's actually pretty easy to convert to rectangular. Right? If I try to convert to rectangular, you don't have to, but if you try to convert to rectangular, we have r equals -2 divided by the sine of theta. Right? That's -2 cosecant theta. Then multiplying by sine theta, we have r sine theta equals -2. And remember, r times sine theta in rectangular is the y coordinates. So y equals -2. That is this line. Remember, the graph of y equals some number on the xy plane is just a horizontal line. And let me show you on that Desmos website. Here's desmos.com. It's a free online graphing calculator. So first I'll put in the polar equation they gave us, right? R equals -2 times the cosecant of theta. And look at that, right? See that horizontal line showing up? And like I said, it's the exact same thing as y equals -2. And see that blue line, y equals negative. It's the same equation. But, one's in polar, one's in rectangular. Okay? So yeah, maybe a little trickier to see here, but this is a line, right? A horizontal line. Looks like this one here. Oh, no. Yeah, that's radius of 2. So, yeah, this y equals -2. It's this one right here. Okay. So yeah, so sometimes pretty tricky to graph these things. All right. You might want to try converting to rectangular and seeing what the graph of that would look like. They'd be the same. But my suggestion to you, especially in the beginning here, this introduction to all these polar graphs, go to a calculator like TI-83, 84 if you want, or Desmos, and look at the pictures there, right? And you'll see the relationships between rectangular and polar, hopefully. Okay. So again, hopefully watching me go over this, looking at the more instruction, playing around with Desmos.com, looking at the answer explanations when they come up. Really hoping all this stuff helps you out when you work on this on your own. All right. And thank you very much for watching.